Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Data Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You need to orchestrate a pipeline with several Google Cloud services, a batch Dataflow job, then a BigQuery query job followed by a Vertex AI batch prediction. The logic is sequential. You want a lightweight, serverless orchestration solution with minimal operational overhead. What service should you use? The options are: Option A, select Cloud Composer. Option B, select Compute Engine with cron. Option C, select Dataproc with Apache Uzi. Option D, select Cloud Workflows.
To arrive at the correct answer, we focus on the keywords: orchestrate a pipeline, Google Cloud Services, batch Dataflow job, BigQuery query job, Vertex AI batch prediction. Logic is sequential, lightweight, serverless orchestration solution, minimal operational overhead.
The correct answer is option D, select Cloud Workflows.
Why is this correct? D. Cloud Workflows is a fully managed, serverless orchestrator ideal for sequential logic connecting Google Cloud services like Dataflow, BigQuery, and Vertex AI with minimal operational overhead. Why are the others incorrect? A. Cloud Composer is a robust, managed Apache Airflow service that introduces more operational overhead and is heavier than what is needed for a simple, lightweight sequential pipeline. B. Compute Engine with cron is not serverless and requires managing infrastructure, contradicting the need for minimal operational overhead. C. Dataproc with Apache Uzi requires provisioning and managing cluster infrastructure, which is not a lightweight or serverless orchestration solution.
You have a data analyst team member who needs to analyze data by using BigQuery. The data analyst wants to create a data pipeline that would load 200 CSV files with an average size of 15 megabytes from a cloud storage bucket into BigQuery daily. The data needs to be ingested and transformed before being accessed in BigQuery for analysis. You need to recommend a fully managed, no-code solution for the data analyst. What should you do? The options are: Option A, create a Cloud Run function and schedule it to run daily using Cloud Scheduler to load the data into BigQuery. Option B, use the BigQuery data transfer service to load files from cloud storage to BigQuery. Create a BigQuery job which transforms the data using BigQuery SQL and schedule it to run daily. Option C, build a custom Apache Beam pipeline and run it on Dataflow to load the file from cloud storage to BigQuery and schedule it to run daily using Cloud Composer. Option D, create a pipeline by using BigQuery pipelines and schedule it to load the data into BigQuery daily.
To arrive at the correct answer, we focus on the keywords: load 200 CSV files from a cloud storage bucket into BigQuery daily, ingested and transformed, fully managed, no-code solution.
The correct answer is option D, create a pipeline by using BigQuery pipelines and schedule it to load the data into BigQuery daily.
Why is this correct? D. BigQuery pipelines provide a fully managed, no-code solution that effectively automates the daily ingestion and transformation of files from cloud storage into BigQuery without requiring any programming. Why are the others incorrect? A. Cloud Run functions require custom programming, which directly violates the requirement for a no-code solution. B. Writing and scheduling BigQuery SQL jobs for data transformation requires coding, which contradicts the strict no-code requirement. C. Building a custom Apache Beam pipeline requires writing application code, e.g., in Java or Python, which does not meet the no-code requirement.
You are designing a stateful data processing pipeline that reads data from a cloud storage bucket and writes transformed data to a BigQuery table. The pipeline must be highly available and resilient to zonal failures within the S-Central-1 region. You need to configure a Dataflow pipeline ensuring minimal disruption during a zonal outage. What should you do? The options are: Option A, launch the Dataflow job with the region equals us central 1 parameter. Option B, deploy the Dataflow job to a single zone within us central 1 and configure it to use a regional persistent disk to store its state. Option C, deploy the Dataflow job to a single zone within us central 1 and use a multi-regional cloud storage bucket to store its state. Option D, launch the Dataflow job with the zone equals us central 1a parameter.
To arrive at the correct answer, we focus on the keywords, resilient to zonal failures, within the US Central 1 region, minimal disruption during a zonal outage.
The correct answer is option A, launch the Dataflow job with the region equals US Central 1 parameter.
Why is this correct? A. Launching with the region parameter creates a regional Dataflow job. Dataflow automatically distributes workers across multiple zones within the specified region, ensuring high availability and resilience against single zonal failures. Why are the others incorrect? B. Deploying to a single zone introduces a single point of failure. The job will not survive a failure of that specific zone, even with a regional persistent disk. C. Deploying to a single zone fails to provide resilience against zonal outages. If the specific zone fails, the Dataflow job will be disrupted. D. Launching with the zone parameter pins the job to one specific zone, making it highly vulnerable to failures in that zone instead of being highly available.
Your team has created several BigQuery curated datasets containing anonymized industry benchmark data. You want to make these datasets easily discoverable and accessible for querying by external partner companies within their own Google Cloud projects. You need a secure and scalable solution. What should you do? The options are: Option A, publish the datasets as listings within BigQuery Sharing Analytics Hub. Option B, export the datasets to partner-specific cloud storage buckets. Option C, create authorized views for each dataset and grant access to each partner. Option D, grant the roles/BigQuery.DataViewer IAM role to the partner group email addresses on the datasets.
To arrive at the correct answer, we focus on the keywords, make these datasets easily discoverable and accessible, external partner companies within their own Google Cloud projects, secure and scalable solution.
The correct answer is option A, publish the datasets as listings within BigQuery Sharing Analytics Hub.
Why is this correct? A. Analytics Hub provides a secure and scalable way to share data across organizations. It allows you to publish datasets as listings, making them easily discoverable and accessible for external partners to query directly within their own Google Cloud projects without data duplication. Why are the others incorrect? B. Exporting data requires duplicating datasets into multiple cloud storage buckets. This approach is not scalable to manage and does not allow partners to directly discover and query the data within BigQuery. C. Creating authorized views for multiple partners is difficult to manage at scale. Furthermore, it does not provide a mechanism to make the datasets easily discoverable across different organizations. Why are the others incorrect? D. Managing IAM roles directly on datasets for numerous external partner groups is not a scalable administrative solution and does not offer a catalog to make the datasets easily discoverable.
Your organization stores highly personal data in BigQuery and needs to comply with strict data privacy regulations. You need to ensure that sensitive data values are rendered unreadable whenever an employee leaves the organization. What should you do? The options are: Option A, use column-level access controls with policy tags and revoke viewer permissions when employees leave the organization. Option B, use dynamic data masking and revoke viewer permissions when employees leave the organization. Option C, use customer-managed encryption keys, CMEK, and delete keys when employees leave the organization. Option D, use AEAD functions and delete keys when employees leave the organization.
To arrive at the correct answer, we focus on the keywords, highly personal data, BigQuery, sensitive data values are rendered unreadable whenever an employee leaves.
The correct answer is option D. Use AEAD functions and delete keys when employees leave the organization.
Why is this correct? D. AEAD, authenticated encryption with associated data, functions in BigQuery allow encryption at the row or cell level. Deleting the specific encryption key associated with a departing employee permanently renders their data unreadable, crypto-shredding, fulfilling the strict privacy requirement. Why are the others incorrect? A. Column-level access controls restrict who can query the data but do not render the underlying data itself permanently unreadable, failing the requirement for true data destruction. B. Dynamic data masking hides data from specific users at query time but does not encrypt or permanently render the underlying sensitive values unreadable when an employee leaves. Why are the others incorrect? C. Customer-managed encryption keys, CMEK, encrypt data at the table or dataset level. Deleting a CMEK would permanently destroy all data in the table, rather than targeting only the departed employee's data.
To monitor and optimize the BigQuery instance for your team. You notice that a particular daily report that uses a large join operation is consistently slow. You want to examine the query's execution plan to identify potential performance bottlenecks within the join as quickly as possible. What should you do? The options are: Option A, use the BigQuery dry_run command to review the estimated number of bytes, read and review query syntax. Option B, run a query on the information_schema.jobs_by_project view filtering by the job_ID and analyze total_bytes_ processed. Option C, review the BigQuery audit logs and cloud logging. Option D, leverage BigQuery's query history view and analyze the execution graph.
To arrive at the correct answer, we focus on the keywords, examine the query's execution plan, identify potential performance bottlenecks, as quickly as possible.
The correct answer is option D. Leverage BigQuery's query history view and analyze the execution graph.
Why is this correct? D. The query history view provides a visual execution graph, allowing you to quickly inspect query stages, execution details, and identify specific performance bottlenecks within complex operations like joins. Why are the others incorrect? A. A dry run only validates query syntax and estimates the number of bytes read. It does not provide an execution plan to identify performance bottlenecks. B. Querying information_schema provides job metadata such as bytes processed, but it does not offer the detailed, stage-level execution plan required to find bottlenecks within a join. C. Cloud logging audit logs record API access and administrative events. They do not contain the detailed query execution plans necessary for performance optimization.
Your company stores vital operational sales data in a BigQuery dataset in US-Central-1. Your company requires a disaster recovery plan to restore this data to US-East-1 with a recovery point objective, RPO, of 24 hours and a recovery time objective, RTO, of 4 hours if US-Central-1 experiences an outage. You need to implement the disaster recovery plan while keeping costs and complexity to a minimum. What should you do? The options are: Option A, set up continuous queries and pub/sub to stream data changes from BigQuery tables in US-Central-1 to US-East-1. Option B, manually export data to a CSV file in a multi-regional cloud storage bucket daily and use BQ load to restore to US-East-1. Option C, configure BigQuery cross-region dataset replication from US-Central-1 to US-East-1. Option D, take daily BigQuery table snapshots in US-Central-1.
To arrive at the correct answer, we focus on the keywords, BigQuery dataset in US-Central-1, disaster recovery plan to restore this data to US-East-1, recovery point objective, RPO, of 24 hours, recovery time objective, RTO, of 4 hours, keeping costs and complexity to a minimum.
The correct answer is option C. Configure BigQuery cross-region dataset replication from US-Central-1 to US-East-1.
Why is this correct? C. BigQuery cross-region dataset replication natively and automatically synchronizes data to another region, meeting the RPO and RTO requirements while keeping both operational complexity and costs to a minimum compared to building custom solutions. Why are the others incorrect? A. Setting up continuous queries in pub/sub pipelines introduces high operational complexity and significantly increases costs compared to native replication. B. Manually exporting data to CSV files and loading it via scripts is complex, error-prone, and adds unnecessary management overhead. D. Taking table snapshots in the same region, a central one, does not provide disaster recovery to us east one if the primary region experiences an outage.
You are developing a fraud detection model using BigQuery ML. You have a raw transaction dataset and need to create new features such as the average_transaction_amount_last_24_hours and time_since_last_transaction. These features require aggregation and time window calculations on the existing data. The goal is to ensure that these features are consistently applied during both model training and prediction without manual intervention. You need to prepare these features efficiently for your model. What should you do? The options are: Option A, implement a Cloud Run function that triggers on new transactions, calculates the features, and inserts them into a feature store before model serving. Option B, export the BigQuery data to cloud storage, perform feature engineering using a custom Python script in a Dataflow job, and then re-import the engineered features into BigQuery. Option C, use the transform clause within the create model statement, leveraging SQL functions for aggregations and time-based calculations. Option D, create a separate BigQuery table containing pre-computed features using complex SQL queries and join this table with the raw data during model training and serving.
To arrive at the correct answer, we focus on the keywords BigQuery ML, consistently applied during both model training and prediction without manual intervention.
The correct answer is option C. Use the transform clause within the create model statement, leveraging SQL functions for aggregations and time-based calculations.
Why is this correct? C. The transform clause in BigQuery ML embeds data pre-processing directly within the model. This ensures that any feature engineering is consistently and automatically applied during both training and prediction, eliminating the need for manual intervention. Why are the others incorrect? A. Implementing a Cloud Run function adds unnecessary complexity and external components. It doesn't natively integrate with BigQuery ML's training and serving pipeline, requiring manual coordination to ensure consistent feature calculation. B. Exporting data and using Dataflow introduces a complex, external pipeline. It requires manual intervention to maintain consistency between the offline engineered training data and online prediction requests. D. Creating a separate table for pre-computed features requires maintaining an independent pipeline. It does not automatically guarantee that the exact same feature transformations will be applied seamlessly during prediction.
Your organization has thousands of images stored in cloud storage. The organization's data analysts need to categorize these images upon analyzing the image content and store the results in a structured format for integration with other BigQuery datasets. You need a solution that allows the analysts to perform this task with the least amount of coding. What should you do? The options are: Option A, use the Gemini 2.5 Pro model in Vertex AI to analyze the images and store the results in BigQuery. Option B, use the ml.understand_text function along with object tables to analyze the images and store the JSON output in a cloud storage bucket. Option C, use Vertex AI Vision API to analyze the images and store the results in BigQuery. Option D, use the ml.generate_text function along with object tables to analyze the images and store the JSON output in a BigQuery table.
To arrive at the correct answer, we focus on the keywords images stored in cloud storage, categorize these images, analyzing the image content, structured format for integration with other BigQuery datasets, least amount of coding.
The correct answer is option C. Use Vertex AI Vision API to analyze the images and store the results in BigQuery.
Why is this correct? C. Vertex AI Vision API provides powerful, pre-trained models specifically designed to analyze and categorize images with minimal custom coding, allowing for straightforward integration of structured results into BigQuery. Why are the others incorrect? A. Utilizing Gemini models directly in Vertex AI requires more extensive custom coding and orchestration to analyze images and build a data pipeline compared to using the purpose-built Vision API. B. The ML.understand_text function is designed for analyzing text, not images. Additionally, storing the output in cloud storage fails to meet the requirement for direct integration with BigQuery datasets. D. The ML.generate_text function is primarily intended for text generation and natural language tasks, rather than the visual categorization and analysis of image content.
You are building a system to process financial transactions. The system must handle a high throughput of concurrent user operations, and each operation requires low latency reads and writes to individual records. You need to identify a storage solution that guarantees ACID compliance for the processed transactions. You want a Google Cloud managed service. What should you do? The options are: Option A, select Bigtable. Option B, select BigQuery. Option C, select Cloud Storage. Option D, select Spanner.
To arrive at the correct answer, we focus on the keywords: financial transactions, high throughput, low latency reads and writes, ACID compliance, Google Cloud Managed Service.
The correct answer is option D, select Spanner.
Why is this correct? D. Spanner is a fully managed, scalable relational database that provides high throughput, low latency reads and writes, and global ACID compliance, making it the ideal choice for processing financial transactions. Why are the others incorrect? A. Bigtable offers high throughput and low latency but only supports single-row transactions. It lacks the multi-row ACID compliance required for financial transactions. B. BigQuery is a data warehouse optimized for analytical workloads, OLAP, and does not support the high throughput, low latency transactional workloads, OLTP, required here. C. Cloud storage is an object storage service, not a database, and is entirely unsuitable for high throughput, low latency transactional reads and writes requiring ACID compliance.
You are preparing data to serve a sales demand prediction model. The training data undergoes several pre-processing steps, including scaling numerical features and one-hot encoding categorical features. The model is deployed on Vertex AI endpoints. You need to prevent training serving skew and ensure accurate predictions in production. You want a solution that is easy to implement. What should you do? The options are: Option A, implement a custom handler within the Vertex AI endpoint to automatically perform data transformations before the model makes a prediction. Option B, replicate the exact same pre-processing logic in the inference pipeline that was used during model training. Option C, store the raw, unprocessed data in a separate cloud storage bucket exclusively for serving. Option D, ensure the serving data is a smaller, random sample of the training data.
To arrive at the correct answer, we focus on the keywords: pre-processing steps, scaling numerical features, one-hot encoding categorical features, Vertex AI endpoints, prevent training serving skew, easy to implement.
The correct answer is option B, replicate the exact same pre-processing logic in the inference pipeline that was used during model training.
Why is this correct? B. Replicating the exact same pre-processing logic in the inference pipeline ensures that serving data undergoes identical transformations as training data, directly preventing training serving skew simply and effectively. Why are the others incorrect? A. Implementing a custom handler requires writing, testing, and maintaining custom serving code, which adds unnecessary complexity and violates the requirement for a solution that is easy to implement. C. Storing raw, unprocessed data does not prepare it for inference or address training serving skew, as the model requires properly scaled and encoded features to make accurate predictions. D. Serving data consists of live, incoming production requests, not a random sample of the training dataset. Sampling training data does not resolve pre-processing discrepancies or prevent skew.
Your retail company is concerned about their BigQuery analytics spend. The company runs several queries that require the use of the same aggregation for the store ID and real-time sales volume. You need to implement the optimal solution that minimizes analytics spend and returns faster results. What should you do? The options are: Option A, create a new table from a CSV file with the repeated aggregation for the other queries to reference for faster processing. Option B, create a materialized view to minimize repetitive computations. Option C, use join acceleration with primary and foreign keys to increase query joining to live data. Option D, leverage partitioning to minimize the number of bytes read.
To arrive at the correct answer, we focus on the keywords: same aggregation, real-time, minimizes analytics spend, faster results.
The correct answer is option B, create a materialized view to minimize repetitive computations.
Why is this correct? B. Materialized views pre-compute and cache the results of queries, increasing performance and efficiency. They automatically refresh to provide real-time data while minimizing redundant computations, which reduces overall analytics spend and returns faster results. Why are the others incorrect? A. Creating a static table from a CSV file is a manual process that cannot provide real-time data and introduces significant maintenance overhead. C. BigQuery does not use primary and foreign keys for join acceleration in this context, nor does it address repetitive aggregations. D. While partitioning minimizes bytes read, it focuses on filtering data by specific column ranges and does not pre-compute or optimize repetitive aggregations.
You are defining the data governance strategy for a new BigQuery table with medical and financial data. You want a scalable solution that ensures the clinical researchers can access patient medical data without financial information, while allowing the accounting team to access only financial data with minimal patient identifiers. What should you do? The options are: Option A, implement column-level security policies in BigQuery tables with IAM permissions. Option B, create separate tables for personally identifiable information, PII, financial data, and anonymized medical data. Use IAM permissions to control access to each table. Option C, implement row-level security policies in BigQuery tables with IAM permissions. Option D, create separate datasets with authorized views exposing only approved data.
To arrive at the correct answer, we focus on the keywords: scalable solution, clinical researchers can access patient medical data without financial information, accounting team to access only financial data with minimal patient identifiers.
The correct answer is option D, create separate datasets with authorized views exposing only approved data.
Why is this correct? D. Authorized views are a highly scalable solution to provide granular access. By creating separate datasets for views, you securely expose only the permitted columns to researchers and accountants without granting access to the underlying base table. Why are the others incorrect? A. While column-level security is possible via policy tags, authorized views provide a more traditional and scalable approach for segregating access to data subsets for distinct groups without managing complex tag permissions. B. Creating separate physical tables duplicates data, which increases storage costs and creates synchronization overhead, making this approach highly unscalable and difficult to maintain. C. Row-level security filters data based on row conditions, but this scenario requires restricting access to specific columns, financial information and patient identifiers, making row-level security inapplicable here.
You are designing a data lake on Google Cloud to store vast amounts of customer interaction data from various sources, such as websites, mobile apps, and social media. You need to ensure that this data, which arrives in different formats, is consistently cataloged and easy for data analysts to discover and use. You also want to perform basic data quality checks and transformations before the data is consumed by downstream applications. You need an automated and managed data governance solution. What should you do? The options are: Option A, use cloud storage as the central repository. Use Vertex AI to classify and process the data and perform data quality checks. Option B, stream all the data directly into BigQuery, where it is automatically cataloged and governed. Option C, use cloud storage and BigQuery as repositories. Use Dataflow's Universal Catalog for metadata discovery, data quality checks, and transformations. Option D, use cloud storage as the central repository. Use a Cloud Run function to catalog, transform the data, and perform data quality checks.
To arrive at the correct answer, we focus on the keywords. Data lake on Google Cloud arrives in different formats: consistently cataloged, discover and use, data quality checks and transformations, automated and managed data governance solution.
The correct answer is option C, use cloud storage and BigQuery as repositories. Use Dataflow's Universal Catalog for metadata discovery, data quality checks, and transformations.
Why is this correct? C. Dataflow is a managed data governance solution offering a universal catalog for metadata discovery across cloud storage and BigQuery. It features built-in automation for data quality checks and transformations, perfectly addressing the requirements for governing diverse data lakes. Why are the others incorrect? A. Vertex AI is a machine learning platform, not a tool for general-purpose data cataloging, metadata discovery, or managed data governance across a diverse data lake. B. BigQuery is a data warehouse optimized for structured data. Streaming unformatted or diverse data directly into it is ineffective and does not natively provide comprehensive data lake governance. D. Cloud Run is a serverless compute environment. Building custom cataloging and quality checks on it creates significant operational overhead and fails to meet the requirement for an automated, managed data governance solution.
You are using Dataflow to build a streaming data pipeline to analyze user website click activity from pub/sub. You need to calculate the number of clicks for each user site visit. A site visit is defined as a period of activity followed by 30 minutes of inactivity for a specific user. What should you do? The options are: Option A, use tumbling windows with a 30-minute window. Option B, use hopping windows with a 30-minute window and a 1-minute period. Option C, use hopping windows with a 30-minute window and a 30-minute period. Option D, use session windows with a 30-minute gap duration.
To arrive at the correct answer, we focus on the keywords, period of activity followed by 30 minutes of inactivity.
The correct answer is option D, use session windows with a 30-minute gap duration.
Why is this correct? D. Session windows dynamically group events into sessions defined by periods of activity separated by a specified gap duration. This perfectly matches the requirement of capturing a period of activity followed by 30 minutes of inactivity. Why are the others incorrect? A. Tumbling windows use fixed, non-overlapping time intervals. They cannot dynamically group user events based on variable periods of activity and inactivity. B. Hopping windows use fixed, overlapping time intervals. They are incapable of defining dynamic sessions based on inactivity gaps. C. A hopping window with a period equal to its window size behaves like a tumbling window, using fixed intervals rather than inactivity gaps.